Assalamu alaikum friends. So today we are going to study about merge sort algorithm. I have already taught you about all other type of sorting algorithms. So today we will focus on this merge sort algorithm, and we will understand that what are the plus points and advantages and how does it work. So the first thing that we need to understand when we talk about merge sort algorithm is that it is a divide and conquer strategy. It is a very powerful strategy. You know that merge sort is a very popular sorting algorithm because it has a n log n time complexity. Even if it is a best case, average case, or worst case, in all these three cases it gives you a n log n time complexity, unlike n square complexity, which is quite a big time complexity. You have studied bubble sort with me and you noticed that the complexity was n square. Similarly, you studied selection sort with me, and you must have observed that the complexity was n square. But the plus point of this merge sort that it is based on divide and conquer, and because of this the comparisons are less. It is not comparing everything with everything. So the complexity is n log n. So you always, if you are given a choice, then you will always opt merge sort over other algorithms because of its very less time complexity as compared to other sorting algorithms. Okay, so now we are going to focus that how does it work. So a simple rule of thumb that you have to remember in the case of merge sort, that it keeps dividing your array until it is so small that it contains only one element. So the thumb rule on which this algorithm works is recursion and termination. Recursion, by recursion I means that it keeps on dividing again and again, again and again. And by termination I means that I mean that you have to divide it unless there is only one element left in your array. So if you remember these two rule of thumbs, then you will always be able to perform merge sort. Whenever you are asked to solve any example by merge sort, you have to keep this in your mind, that you have to divide recursively unless and until you terminate onto a single element array. Okay, so now we are going to solve an example to further elaborate upon the concept. So I have actually taken this array which contains 1, 2, 3, 4, 5, 6, 7, 8, 8 elements. For the sake of easiness, I took an 8 numbered element. Even you can take an odd number element, that is not a big deal. Okay, so what you are going to do, you are going to divide it into two subarrays. So I have made this subarray 1 and this subarray 2. So I will keep on doing this division recursively unless and until I reach onto single elements. So from this 4 array element I got these 2 and 2 subarrays. From these 4 elements I got this 2 and 2 subarrays. So from one array now I have 1, 2, 3, 4 arrays. And when I recursively divide it again, I have got these 1, 2, 3, 4, 5, 6, 7, 8 arrays. So actually I will terminate on this point. My division will terminate on this point because now I have reached a single element array. If there was a odd number of elements array, then of course this would have been maybe a 5 element array, and this could have been a 2 element, then there could be 3 and 2, and then there could be there could be 2 and 1, and then it could be 1 and 1. So that is not a big deal. You can simply divide it into 5 and 3, 5 and 4. That is not a big deal. The real thing is that you have to terminate it in the way that there should be 1 1 1 1 1 in the end. Okay, so till now I think everything is clear that we have divided it. Now comes the next part, which we call the merge and conquer portion of this algorithm, and this is the portion where we are actually going to perform sorting. So now I'm going to tell you that how we are going to do that. So first of all, you are going to merge these two elements, these two single element arrays into a two element array. So how you are going to do that? uh, you can simply compare these two elements, right? This is not a big deal. So you compare 6 with 4, and of course 4 is smaller than 6. So you will put 4 in the beginning and 6 later. Similarly, you compare 2 and 1 and you can sort them very simply. Similarly, you compare 9 and 8 and you can sort them very simply. And for 3 and 5, they are already sorted, so you will simply place them into this form. So now you can see that you are going to perform merging recursively. These single element arrays have formed 2 element arrays. Okay, so in the next step we are going to join this 2 element array with this 2 element array, but this is not very straightforward like this previous step. It is not going to be like 4 6 1 2. It is has to be done in such a way that these elements 4 6 1 2 are also sorted out in the form of their ascending orders. By ascending order, I mean that the smallest element should appear first and the largest element should appear in the last. So how are we gonna do that? Okay, that's not complicated. There is a simple algorithm or rule of thumb for that. First of all, you can imagine that we have placed a pointer I on the first element, and we call that this is my left subarray, and Li is my pointer that I have placed on the first element of this subarray, and Rj is the pointer that I have placed on the first element of my right subarray. So if I compare these two elements, right, if I compare and if I see that if my first element first array's element is smaller than the second array's element, then I will write the Li first because it was smaller. So of course I understand that in sorting we are moving in ascending order, so we will write the small element first and then I will move my I pointer, this pointer, forward. Otherwise, if my Li was larger, like if this element was larger, as you can see here is the case, then in that case I will write this element first, because you know in ascending order of course the small element has to be written first, and then I will move this pointer forward. I will not change this pointer, I will move this pointer forward. Okay, so let's start applying this algorithm here. So I'm comparing 4 with I, and I can see that this is the smaller number. 1 is smaller than 4. So I'm placing 1 here and I'm moving this pointer j from this position to the next position because this element has already been sorted out. Okay, so now I will compare 4 with 1, and you can see that of course 1 is sorry yeah 4 with 2, then you can see that of course 2 is smaller than 4, so I will move this 2 here. Okay, now what to do, how to compare 4? So I will place an infinity here and I will compare 4 with infinity, and of course 4 is smaller than infinity, so naturally 4 will come here, and when this 4 is coming here, so according to this rule now the pointer I will move forward. So the pointer I will move to the 6th position, and now 6 is going to be compared with infinity, and it means 6 is smaller than infinity, so it will come here. So basically it is very simple that we are comparing each element of these subarrays and placing the smaller one first, then the next bigger one, then the next bigger one, and then the next bigger one. It is very simple. Okay, now coming on to these two arrays, so again you have placed a pointer here and you have placed a pointer here. You compare 8 with 3. Of course 3 is small, so 3 comes here, and in the next comparison you are going to compare this 8 with this 5, and 5 is small, so 5 will come here. In the next step you are going to compare this 8 with infinity, so of course 8 will come here, and then 9 is the only one left, so 9 will directly come here. And now I'm going to merge these 4 element subarrays into the larger one. So again I'll place a pointer here and I'll place a pointer here. 1 is compared with 3, and of course 1 is smaller than, so that means 1 will come first. Okay, let's move the pointer forward on position 2. 2 is compared with 3, and of course 2 is smaller, so 2 will come here. And then I'm moving my pointer forward. 4 is compared with 3. 3 is smaller, so 3 is coming here. Okay, let's move the pointer forward. 4 is compared with 5, and of course 4 is smaller, so 4 is coming here, right, and moving the pointer forward. 6 is compared with 5, so of course 5 is smaller, so 5 is coming here and the pointer is moving forward. Then 6 is compared with 8, of course 6 is coming here, and then the pointer will move to infinity, right? So when it moves to infinity, then of course naturally infinity is not smaller than anything, so 8 and 9 will naturally come here. So you do not need to, you will simply make comparisons with infinity. So in this way you have actually sorted out this complete array. The elements which were very random, you can see that now this is small, and you can see that it is in the ascending order. You need not to compare each element with each element. In fact, you divided them into two parts. That is why the complexity said log of n, because you performed division. And why is there an n? Because you had to do this division n number of times. For example, if you had 1 2 3 4 5 6 7 8, so you can see that 1 2 3 4 5 and 6, and if you add into it, you have done it n times,